Hello, today we are going to talk about the UNIX command line executables. How are they standardized, how they work on Linux or macOS or Solaris, any other type of operating system that is Unix-like, how they are combined using pipes, redirection, to generate more complex functionality from simple building blocks, which are the executables themselves. So on YouTube, there's the channel of RWXRob, which he teaches the Unix command line. This is because he says that Unix command lines are so standard and available over a multitude of operating systems on embedded development, on a DevOps scenario, in virtual machines, in containers. If you do DevOps, if you do pen testing, if you do Unix sysadmin, Linux sysadmin, FreeBSD sysadmin, you're going to have many situations when you only have the command line. So either if you're connected locally with your keyboard and mouse, or over SSH, for instance, but you don't have X graphical user interface or Wayland, you just have the plain command line, and maybe you're not even a super user, so you can't install additional text editors and packages, so you need to use what's out of the box in there because you're a regular user. Okay, so let's do something really similar to what RWXRob does. So let's see what's really available. If you can't use the graphical user interface, you just have the command line, access to the command line, and what can you do, and without installing packages, without being a super user. Okay, so the Unix and Unix-like operating systems have a kernel space and a user space. So the kernel space could be really minimal if the kernel is a microkernel that's not monolithical. But most Unix-like operating systems do have a C standard library, do have man pages for the functions in the C standard library, do have a shell, a command line shell such as bash, and do have the standard Unix executables such as vi for editing, sed for command line text batch style text editing, vi for interactive style editing of files, ls for listing files and for listing directories, rm for deleting the files or directories. Okay, so whether you have musl or glibc or uclibc as a C library, you usually can depend on having Unix style executables in your operating system. So let's see various operating systems and Docker containers and see what are the command line executables that are commonly available. And there's also a standard for this. So the portable operating system interface POSIX is a family of standards from IEEE for maintaining compatibility between operating systems. defines APIs, so functions, shells. So what's the minimum functionality that must exist in the sh shell, which is the Unix compatible shell, not bash, not bash, but the sh shell. Utility executables. So as standard, many operating systems respect in broad lines POSIX standards. So we have process, Unix style process creation with the fork API call function, signals with kill, pipes with the vertical bar pipe, which takes the standard output from command line from process 1 and takes the standard output from command 1 and puts it as standard input into the process specified by command 2. And that takes the standard output from this process and puts it as standard input into this process. So standard output input connection between program 1 and program 2. And since stdr is not redirected in any way in this example, stdr is always connected to the display. It's connected to the shell, and the shell is connected to the terminal, and the terminal is connected to the display. Okay, and the standard output of program 3, of command 3, is not connected to anything, so it's connected to the display in here. And since we don't give any standard input into command 1, then command 1 takes the standard input from the keyboard. Okay, so this is piping between processes. And we also can have redirection, which like this, from into this process, redirect the standard output of this thing as standard input, and redirect to file with greater than, which rewrites the destination file, or greater than, which appends to the destination. Okay, so let's take, for instance, this example and see how far we get with it. So we open this thing, so we're in a graphical user interface. So this is the X server with this is kwin, the window manager, and compositor. This is the KD Plasma desktop and desktop environment. So the terminal is called console with a K. Inside of the console of the terminal we have the command line shell, which is bash, this guy. Control D to exit it. Okay, and in there we can run complex command line incantations. So let's see. We can select and then mouse middle click, paste. And let's see what gives. So we went curl and then a URL. So that thing took the source code of this file, view page source, this thing, and has written it to the standard output inside of bash. Okay, so again curl this thing, middle click paste, and then let's see with the paginator what it really does. So it writes HTML class client Node.js. View page source. So it starts with HTML class client Node.js, lang en, dir ltr, head, UTF-8, title, script. So in Firefox source code view, we have a left to right scroll. So the lines are not wrapped, whereas in the terminal, almost always the lines are wrapped. That's why the script takes 4 lines in Mozilla Firefox source code viewer, whereas it takes 20 lines in my terminal, because my terminal is line wrapped. Okay, then script a really huge line, and in here it's shown on 2 lines, then link a long one and 3 lines in the terminal, script one in the terminal, meta link and then a ton of metas, meta link and then a ton of metas. Okay, so it just asks the HTTPS server from any Wikipedia or wiki pipeline, UNIX, please tell me the body of this page, and then the body of this page is written to standard output, the standard stream. Okay, so what if we do this thing? So take the standard output from curl, which is the source code of this page, and then apply sed to it. So we go sed global replace with space of everything. So this is regular expression of just one character. So it's between right parentheses. So it says not English dictionary and not space. So whatever is not English word or an character in the English alphabet, or space. If it's not space, then replace with space. If it's not in the English alphabet, this character, replace it with space. So this is, let's try the 2-liner, copy, paste, and again with less to see what's in there. Okay, view page source. So it took less than, and it's not in the English alphabet, so it replaced it with a space, this guy. Then HTML, all of these 4 characters are in the English alphabet, so it kept it. Space, it kept it as is, didn't do any replace. Class, C is in the English alphabet, so it wrote it. L is in the English alphabet, so it wrote it to standard output. A is in the English alphabet, so it wrote it. Equals is not in the English alphabet, so it replaced it with 1 space, this space. Double quote is not in the English alphabet, so it replaced it with a space. Client is, wrote it in here. Minus is not, so it put a space. Node.js is, wrote it in here. Double quote is not, so it put a space. Equals should not be space should not be replaced. Lang should not be replaced. Equals double quote should be replaced with spaces. En should not be replaced. Double quote should be replaced. Space should be kept as is. Okay. So what it did, it deleted all of the non-English characters. So it removed less than and greater than, which is really common in HTML, for instance, or removed source code parentheses. Okay. So we press Q, we're inside the paginator less, so we can exit with Q. Okay, what else? It says translate all of, if a character is in the subset uppercase A, uppercase B, uppercase C until uppercase Z, then we replace that character with the equivalent lowercase character. If it's a space, we replace it with new lines. So space replaced with new lines, uppercase A replaced with lowercase a, uppercase Z replaced with lowercase z. Copy, so it makes everything lowercase. Again with less to paginate. So spaces were replaced with new lines before doc type. Okay, so wherever before doc type there was a less than, first it was replaced, the less than character was replaced with a space, and with tr we replaced it with from space to new line. So that space became this new line. After HTML there is a space that got converted to a new line, this thing. No, not that. So it's about this thing. So it's no, this got replaced with how many new lines? One new line. Okay, so this got replaced with spaces in the first part, and then with new lines. This doc type has been kept in the first transformation, and then has been lowercased with dr. This space became a new line. HTML was kept as it is because it's English and lowercase. This became a space and then a new line, this guy. And this became a there was a new line already, this guy. So from at the end of line 1 to the start of line 2, so that was kept. This is this guy. And then this less than before HTML is this new line. And then there's HTML, English and lowercase, then new line. So space was kept first and then translated to new line, and then class, which is English lowercase. And then these are not English lowercase, so not even English. So a new line and then a second new line. Client, after client is a minus of a new line. Node.js, after Node.js we have two non-English things, so one and two new lines. Long, two non. Okay, so it kept just the lower case English characters, not words, unchanged. The uppercase English one characters got lowercase, and the rest was replaced with new lines. Okay, and then we go grep a minus z. So that will return just the lines that contains at least one English character. This will eliminate the empty lines. So this is an empty line between long and en. There's an empty line. This will be eliminated. Q to exit less, paste, and then less. I pasted the wrong thing. Should also paste the grep. Okay, so no empty new line, no empty line. Q. Then it sorts minus U. What does that thing mean? So what is sort? Is it an executable or a bash built-in? Let's see. So it's an executable with a path /usr/bin sort. And it has a man page. Yes, it has a man page. So man space the number of the name of the executable, sort in this case. So minus U, what does that thing mean? How do we navigate with within a manual page? So the manual page is paginated using, I'm guessing, less. So less in Unix is the paginator that allows you to use the up and down arrow keys. The other paginator, more, doesn't allow you to scroll up if you press the up key. In other operating systems, more is just an alias for less. So more paginator accepts space to go page down to go page down. It doesn't scroll back, so page up doesn't scroll back. Up arrow doesn't scroll back. You just have the possibilities scroll down, page down with page down key or with the space key, and one line down with the down arrow key. Okay, so we're in luck that man paginates using less. In order to search in less, we use the slash. So the slash key on the keyboard, and then we want to find the U. So let's go, for instance, with minus U, and then enter. So we went slash minus U, enter. So it says unique. So it sorts, but it removes the duplicates. Okay, let's see what that does. Copy, paste, and then the vertical bar, and then less, which is the paginator. So it's ordered alphabetical ascending, and there's no duplicates. So I'm pressing the down key. So it's sorted and unique. I can move inside the less with page up or page down. Space is the same as page down, the space key. Scroll up and down using the arrow keys on the keyboard. I can search with slash and I don't know, E. So it finds all of the E's and jumps into the first E. Okay, so that was search. Escape to exit search. Or not. And then there's N for next search occurrence. So it jumps from E to E. Let's go with, let's search for, I don't know, GE. Enter. So it's jumps to the first G in large. And now if we go N, it will go to entity page. And then to gadget. So I'm just pressing N, the N key, next. N for next. Okay. But instead of just paginating, sometimes the better alternative is to use a real text editor. So for instance, mansort, you can search for -u with /-u and enter. That's a thing. Or you could go just mansort and redirect this thing to a file. So we redirect the output of man to a file such as a.txt. Okay, and now we can use a real text editor to look inside of it. Whatever is your real text editor, could be Emacs, right? No. Yes. Could be, I know, Kate. Right, so it's way easier to do your things, such as searching and paginating, page up, page down, copying, etc., using the text editor that you know better than less or more paginators. So I can go -u, right? I don't know, Visual Studio Code, whatever you prefer. Right? And you have a grep and everything. So that thing was redirecting the standard output not to another process, but to a file. So when you redirect to another process, you use the vertical pipe, and when you want to redirect to a file, you go more than, greater than sign. If you want to append, you can go double the greater than sign. So this appends. So now this file is really, really huge. If we search for control with or -u, we will find it many times. So once, twice, 3 times, 4 times, 5 times. So that was 4 times the append redirect to file. So it takes the standard output out of this process and writes it to this file and appends to this file. If you want to do rewrite, so not append but delete all of the contents of the file and then put just the standard output of this command into that file, so not append but rewrite, then we go greater than. Control F -u finds it just once on line 101. Okay, what is clear? Clears the terminal. Clears the terminal, so it has a man page, so we can go man clear. And it's from the package ncurses. Tput terminfo clear. It might be a symbolic link to tput. Let's see that. which clear usr bin clear ls minus la slash usr bin clear. So doesn't seem to be a symlink. And neither is dput. And they have different sizes. Okay. So with ls we list a file, with -l we list the long version of the list of the details of that file, and with -a we show files that are hidden. Okay, so we have man clear, we have which clear, which tells us the path of the executable file. So this clear is an executable file. Let's look inside of the clear executable. So we can go emacs/usr. Let's go with a full path clear. Okay, it's an elf file. You can see these three ELF characters. So that means it's a Linux native binary format. It's not a shell script, for instance, or a Perl script. Okay, exiting Emacs is with Ctrl X, Ctrl C. Okay, so let's run the entire thing. Let's see if this file exists. Copy, we can go ls and then paste. And if it returns something, then the file exists. If we go ls with a file that does not exist, it says cannot access this file, no such file or directory. So with ls space the name of the file, we can find out if the file exists or not. So let's run the entire UNIX pipeline. So what it does, so we went until here. So it has only English words and unique and ascending. And then this thing takes only the words that I don't know, are in the dictionary or something. Let's see how it's finds lines in common between two files. So COMM, an executable that tells us which lines are common between two files. So -23 suppresses lines unique to the second file and those that are common to both. So 1, 2, 3 meaning the left hand side file, the right hand side file, and those that are common. So it doesn't show words that are in the dictionary. It doesn't show words that are just in the dictionary, not words which are in the output of sort and also in the dictionary. So just the things that are not in the dictionary, just the things that are not valid English words. Minus takes the first file from takes the one of the file from standard input. So one of the files is the content of one file is this thing, the standard output of this pipe, and the other file is this sort usr share dict words, the standard output of this command. Okay, so this will order the English dictionary. This is the English dictionary. These are words which are valid in the English dictionary. the ones with uppercase come first. So these are mostly person, nouns, and okay. And now with add lowercase words. Sure. And just for extra safety, it doesn't list the words as doesn't list the content of the file as it is. It also sorts the content of the file to make sure it's really sorted. And this thing also mixes the lowercase z's with the uppercase z's. So it whereas less had just uppercase a's in the first pages, words starting with uppercase A. Sorting will have uppercase and lowercase a on the first page. So this is a sorting case insensitive, whereas this is a sorting case sensitive. So sorting case sensitive, sorting by ASCII code of the first character, which is A, is uppercase A comes before uppercase B and before lowercase a in the ASCII chart. ASCII chart being this table. This thing. So uppercase A is decimal 65, uppercase B is decimal 66, and the lowercase a is decimal 97. So that's why uppercase A is before lowercase a, and uppercase A is before lowercase b. Okay. Less is the paginator. Okay, and then there's another output stream which is called the error stream. Sometimes used for errors, sometimes used for other things. Okay. We can redirect output to dev null. For instance, if we go sort /usr share dict /words, it will write the output of this command, sort /usr share dict words, to the standard input of the parent. The parent is bash, so we will see it inside of the terminal. Okay. But what if we don't want to see at all the output of this command? We want to run a command line and we don't want to see the output at all. So we go redirect the standard output to dev null. So uppercase space /dev /null. Okay. And now only the other output stream, standard error, will be shown to the inside of this terminal. So again, any command has two output pipes. One is standard output and the other is standard error. By default, all of these are connected to the parent. The parent is bash and the parent of bash is console. So the standard output of bash is connected to the console. That's why we see whatever bash writes. The standard output of sort usr share dict words is connected to its parent, which is bash. That's why we can see the output of sort. If we redirect the standard output to dev null, we will not see the standard output, but we still can see the standard error because that thing was not redirected. So the redirection of standard output and standard error is independent. You can redirect both to something, just standard error or just standard output. Whatever you don't redirect will be sent to the parent and generally shown in the terminal. Okay, so ls exists on the hard disk. It's /usr/bin/ls. grep exists on the hard disk /usr/bin/grep. less exists 90% of the things that you write in the command line exist as executables, and the rest are shell built-ins. For instance, shopt shopped is a built-in. Exit is a built-in. Unset is a built-in. Alias, declare, typeset, export, read-only, local are built-ins. BG is a built-in. Even if they are built-ins, some of these still exist on the hard disk as executables. This is because not all shells have the same list of built-ins. So if you have a shell with less built-ins, you still will be able to execute that command, and that command will not be a shell built-in, but will be executed by executing a thing from /usr/bin, for instance. Okay, such as set, which set. Okay, does not exist on the hard disk, so it's a bash built-in, but if you run another shell, set should be built in that other shell if it's POSIX compliant, if it's a POSIX compliant shell. Okay, keep POSIX shell. So there's bash in Ubuntu, I mean Ubuntu 22.04. So the defaultest shell in here is dash. So which sh is /usr/bin/sh. And that thing is dash, command line interpreter shell, BSD general commands manual. Dash is simpler than bash. That's why it should start faster and use less memory and have some advantages over bash. But then bash is better in every other way. It's easier to program for bash. It's easier to use it. Everything is better. When using interactively, you should almost always use bash, not dash. Dash is bare bones, meant for, for the running init scripts really fast. So when a computer starts, it runs millions of shell scripts. So that's why and millions of shell processes. So it makes sense that those shell processes start faster, use less RAM, use less CPU, have less features, finish their thing faster. Dash is a direct descendant of the NetBSD version of Almquist shell. Renamed to Dash in 2002. Okay. There's other shells, corn shell, KSH, Z shell, TCH, C shell. And the cool one this moment is fish, FISH. Okay, RC, the command line interpreter in another operating system which is called Plan 9. Okay. Next. So we know how to combine individual executables, we know what's a shell, we know how to paginate, we know how to use a graphical user interface editor, interactive editor, but then how do we use the other things? So for instance, we have a FreeBSD VM. We know its IP address, it's this thing. Let's connect to it. SSH. I don't know, how do I connect to this thing? Paste. Password. Okay, so we're in. SSH allows us to connect to another machine. That machine could be on another computer, could be a virtual machine on this computer, or could be a chroot on this computer, or could be a container such as I don't know, what's the container technology? Docker, okay? Such as Docker, or could be a combination of these. So you could be connected to a remote machine, and from there you could be connected to another remote machine, and from there you could be connected to a VM, and in that VM you could be connected to a Docker. So this is where the power of Unix command line shines through. When you're connected via 10 hops, you know, to another machine, to another machine, to virtual machine, to virtual machine, to a cloud, to a container, something like that. So when you must jump through many hoops to reach your final destination, everything works correctly if you're inside of the terminal. So in this case, I'm connecting to a different machine which is virtual, which is this virtual machine, via SSH. You could connect to other technologies than SSH, but then SSH is the golden standard. You should learn SSH and try to use SSH, and SSH should be provided always. Whenever there's a need to manage that machine from the exterior, you should always expose SSH if needed in a firewalled manner, just to a list of IP addresses that can connect to their machine, or throttled, or SSH should be hardened, but then SSH should be available on 90% of the machines, something like that. Okay, so we're in SSH and in FreeBSD. So if we run locally various commands on Kubuntu 2204, my hardware machine, such as uname -a, it will say it's the Linux kernel version 5.15. SMP means more than one CPU core, and x86. Whereas in side of this FreeBSD machine, if I go uname -a, it will say the FreeBSD kernel, so not the Linux kernel. Let's put this side by side. Copy. Control V versus whatever is in here. Select and middle click paste. So the kernel is not Linux, it's FreeBSD. The machine is not 1c595fd0, is FreeBSD. The version is not 5.15, it's 13.1. It's not x86-64, it's AMD-64, which is the same thing, right? And even the output of uname -a is really different, because for FreeBSD it doesn't say when it was compiled. For Linux it does say when it was compiled. Okay, this is probably the triplet. So FreeBSD has two different user spaces. User space command line executables. So, two sets of executables. One is from here, this. How do we count this WC? -L. What does WC do? Word, line, character, and byte count. So we want word counting. No, we want line counting. Oh, -L. Let's see if that works. Yeah, so 482 executables exist in what's called a FreeBSD base. So they're inside /usr/bin. Whereas the FreeBSD ports collection is huge, has, I don't know, 80,000 packages, contains probably 1 million executables if we install all of the ports in the ports collection, and all of those will be inside /usr/local/bin. I didn't install all of the possible ports, just some, and still I have 2,300 executables in /usr/local/bin. So the executables inside /usr/local/bin are part of the FreeBSD port collection. Or ports3 or just ports, a set of make files. So it allows you to install many packages on FreeBSD. Not being part of the core, you're not guaranteed that any of the ports is actually installed on your machine. So in this course, we're talking about just the minimum minimorum Unix command line executables that tend to be available on all machines. So that's why we will ignore /usr/local/bin. We can't depend on it, but we can depend on /usr/bin, because when you install FreeBSD, there's no option of not installing base. The installer doesn't give the option to not install base. That's will be installed by default. Okay. So if you look at the path environment variable, there's also /usr/local/bin in there. We don't like that. So for our purposes, whenever we run FreeBSD, we'll trim the path to not include /usr/local/bin, and neither tilde/bin. So we can keep just the directories which contains files which are part of FreeBSD base. So let's do that. Export path equals paste. Okay, and then echo path. So now we've trimmed the parts which are not always there. on any FreeBSD system, which is this part. And if we try to execute an executable from /usr/local/bin, we will not be able to do that. So if you want a vim command not found. If you want Emacs, no fancy editors in the UNIX POSIX standardized command line. Okay. So what are the minimorum binaries that are part of the POSIX standard? Well, some of them we can see if we install FreeBSD base and we look inside the path. So tab gives 1000 possibilities. I go yes. How can I write these to hard disk? Some are built-ins into my current shell, which is wrong because the current shell is bash. And how can we see this? So I should get out of bash because of bash is too fancy, is part of the FreeBSD ports collection. So let's go sh. Which sh? So sh is not /usr/bin/sh, but it's sh. So the POSIX standard probably says that on your path variable there should be an sh. It doesn't really say if that sh should be /bin/sh, /usr/bin/sh, or /usr/local/sh. Okay, the environment variable path is really important. We can go echo $path to see it. That's everything that I wrote in here is standard POSIX, so the existence of sh, the existence of echo, the existence of $path. The fact that paths are separated with colon, not with other things. The fact that directories are separated with slash. The fact that there exists a slash, which is the root directory, which is this thing. ls slash. Okay. The fact that exists an ls, which is /bin/ls in this case on FreeBSD base. Okay, man sh. sh is a FreeBSD base thing, is a command interpreter shell. The standard command interpreter for the system is close to the POSIX specification for the shell, which is IEEE standard 1003.1. which is this thing. The newest version is from 2017. The first version is from 1988. Okay. So various parts of the sh, the fact that sh should exist, and what sh should look like, what built-ins should it have, how it should treat files, file paths, redirects, standard streams, etc. is all standardized by the POSIX standard. And it mimics the original sh from the original UNIX versions. Okay. So we can have export this built-in to set environment variables. We get the contents of environment variables with dollar and then the name of environment variable. Export with no parameters shows the all of the environment variables. This is how we assign a value to the environment variable. We can set an environment variable and then execute the command line so that environment variable will be set just for that command line and its process and its process children. Positional parameters $1, $2. So sh, the shell, is an API. You can write what's called shell scripts, where you have some amenities such as $1, $2 for the parameters of when you run the shell script. Built-in commands. There's a chapter for built-in commands. This is the man page is paginated with more, but more is identical to less in FreeBSD base. So we can up arrow key and down arrow key on the keyboard. You can go page down, page up on the keyboard and space on the keyboard. Okay. / for built-ins. Control operators, dollar, so and sign backgrounds the current command line, and executes the left hand side command line, and if that's successful it executes the right hand side command line. So this is a binary operator, this is a unary operator. This executes left hand side, and it doesn't matter if it's successful or not. When the left hand side finishes, executes the right hand side. So this is a binary operator. This is a redirect append to file. This is redirect overwrite to file. This is the pipe to send std out from the left hand side process to the right hand side process as standard input. You have keywords such as loops, do, done, for, while, until. This is for loops, and then alternative instructions, so if, then, else, elif, and p. And the other alternative instruction structure, which is case and ends with esac. Okay, so but that's when we will see how we can write shell scripts, which is not the part of this short tutorial on what's available on most Unix machines as command line executables. Okay, so if you have a very limited shell on your machine, do use some time to read the manual page for this shell. In time you will learn to read really fast the man pages for the shell. Okay. Okay, so there's an environment variable block. Environment variables usually tend to be all uppercase. Lang is the language, such as English. PWD is the full path to the current directory, etc. So in my case, we go with set to see all of the environment variables. It's just 15. Let's count them. word count minus L, 25 environment variables, not 25 because this is just one, 24 environment variables in the shell that exists in FreeBSD base. And maybe not even that, because I started bash first and then sh from bash. Yes. Okay. So we go tab, it says display all 1000 possibilities. I go Control C, I go clear. Clear still allows me to scroll back. I don't like this thing. Okay. I go tab. It says I see that you want to run an executable. We have many executables. We have 1024 executables and shell built-ins, and some are from /beans, from /sbeans, some from /usr/beans, from /usr/sbeans, so from all the directories that are part of the path. Some are built into this shell sh. Do you want me to display everything? I go yes, display everything. And now I will select all of these. So I scroll with the mouse and drag with the mouse at the same time. So until here. Copy. Okay. So the built-ins and executables available on the hard disk on FreeBSD base are these 1000. In time you should learn most of them. So this is for if conditions in shell scripts. This is sed, the non-interactive batch replacer in files. This is the process that is MTA, mail transport agent, for sending emails. This is a file system checker, checks the hard disk partitions to see if they don't have bad blocks or lost files or corruption. FTP is an FTP client. MD5 computes MD5 sums of the file that you give it as parameter. Awk is kind of like a shell script or Perl script, but somewhere between shell scripts and Perl scripts. More is the paginator. What else? SU makes you a super user. So I'm user administrator right now. Who am I? Tells me who I am, administrator. And I can become another user such as root using SU. Which SU? Mon SU. Substitute user identity from FreeBSD base. It allows you to say the name of the user that you want to switch to. If you don't put such a thing, because it's an optional parameter, optional parameters are enclosed with square brackets, then it will make you the root user. And minus is the most important parameter in here, this minus thing, which says -L, which is simulate a full login. So the environment variables from my shell will not be sent to the shell of the new user that I'm changing it to. User environment is set, so the environment is refreshed, or to be as similar as possible to as it were if I connected straight to the user using the user root, not as I did now via SSH. I connected as the user administrator, and now I'm switching to the user root. Okay. So again, in time you should learn all of these things. ls lists directories. What else? Some things are used for compiling. So M4 is not immediately useful for sysadmins or for DevOps things or something like that, because these are more geared towards developers. Or if you install things from the command line or using ports, then maybe you can need the tools for compiling. So M4 is a tool for compiling C source code into FreeBSD executables and libraries. Okay, make is another such thing. So for developers. These Z things are for compressed. So search inside archives, you would do that with szf grep. Okay, this is the ZFS file system. In Unix, there's usually a number of file systems depending on the operating systems. So on Unix, in Linux, you would have AXD4 or ZFS or BTRFS, PATRFS, or VFAT, or the MS-DOS from Fuse in or ISO or DVD for DVDs or Blu-ray discs. The two most important file systems in FreeBSD or ZFS and UFS. Okay. ln is for symbolic links. rm deletes files and directories. W offers the list of who's connected to this computer. Who is a similar one. Unix systems are generally multi-user, so you can connect many times, multiple times at once. So simultaneously you can connect to the same machine with 3 times the same user and with different 5 users, so at the same time. That's why you have things such as W to see who else is connected to the machine. When you list the processes, you can see which user runs which process. So administrator runs just 4 processes. A SH, which is a FreeBSD based shell. A PSAUX, so PSAUX saw itself. I have a bash, that's what I'm connected with from SSH, and an SSH instance. So I'm connected over SSH. SSH has started bash, and from bash I started SH, and from SH I started PSAUX. And there's an executable for that, which is called PS3, which shows the tree of processes. It's not available as part of the FreeBSD base, and probably not in the POSIX standard. There's another one which is top, which shows in TUI mode, text user interface mode, the list of processes sorted descending by CPU usage. So top uses the most the CPU on this entire machine. And it says it uses 43 megabytes of RAM, and it has 10 gigabytes of RAM or something available. Okay, what else is in there? LL things are for development. These things from low-level This is a low-level debugger, low-level virtual machine, things, compiler, binary manipulation. Okay, last, similar to W, it says who has last connected to this machine, which user and when. Caps is for printers. Cron is to schedule things to run the next hour or 2 times the next minute or something like that, or next week. CP copies file. CLang things are for developers. Some things are really low level, such as the CK things. You almost never use them. Trace for debugging networking issues, you have traceroute. You have ping. For creating empty files, there's touch. For translating, we saw previously how we can translate all of the uppercase A letters into the lowercase a letter. That's tr. What else? This is for converting between code pages, string encodings. BZ is for a zip technology which is called BZ2. bzip. Beehive is the native virtual machine in FreeBSD. What else? Alias is probably a shell built-in, allows you to have a really complicated command line invoked simpler. It's a built-in. N doesn't seem to have a special man page. So you can say whenever I run GG, instead of running GG, you should run ls space minus la space slash, for instance. Okay. Mount lists all of the file systems that are currently running and active. So there's slash, which is backed by the /dev/vt bd0s1a partition, which uses the UFS file system. /dev does not actually exist. So ls/dev, this thing in fact does not exist and is made up by the kernel, by a subsystem inside the kernel which is called devfs, which has a UNIX, which has user space components. procfs, the same thing. /proc does not really exist on the hard disk, so it's not on UFS on this partition. It's in fact in the FreeBSD kernel, exposed as a file system of type procfs and then mounted at /proc. Okay. df shows how much free space you still have. So on slash, we still have 80% free. Free does not exist, but when it exists, it says how much free memory RAM you still have. df is disk free, man df. display free disk space. There's a propose. So it says all of the command lines that could have something with free. So if you want, I don't know, free disk, what does it do? It shows a huge list of things. It should show df in here. So if you zip through this huge list, which you make by using apropos and then some search terms, it will, among others, also show df as the executable that's used to display free disk space. Okay, so there's a way to find out the name of the executable if you know what functionality you want from your executable. But it's really best to just learn what each executable does in just a simple sentence. Grep is for using regular expressions or substrings to find things on the standard input, in files, recursive in files, case sensitive. It's often used like this to when you have way too much standard output and you don't know what to do with it, you say just show me the lines that contain the string df. Okay, so it showed me df something, df something. Okay, this df something, this line contains df, so it has written it to standard output. So it receives lines from standard input. If one line matches, it's going to be written to the standard output. If not, no. Okay. Bmake for developers. Okay, so some tools are from the UNIX standard, some tools are from BSD, some tools are from the GNU project. The tools from the GNU project might have G in front of them, so instead of make, the GNU make could be accessible via the make command line or the gmake command line. The same with BSD things, might have an alias, like this. Okay, why? Because GNU make offers all of the functionality that's required by the POSIX standard, but also has additional features. If you want to just have it use the POSIX features, there's some possibility. There might be an environment variable named POSIXly correct, for instance, or there might be a command line parameter to that executable, such that that executable just forgets that it has any features that are not part of the POSIX standard. So if you just run make, you're not really sure what kind of make is, but you can guess that it has the minimum features that are defined for the make executable as part of the POSIX standard. Okay, let me find that note. POSIX standard make. There should be a PDF with the entire POSIX standard or the many POSIX standards, and in there you can search for make and see what kind of features make should minimorum have on the various operating systems that conform to this version of POSIX. So there's Mac OS, there's the IBM AIX operating system, HP's HPUX operating system, Solaris from Oracle, some dead ones, IRIX, QNX is used for embedded, OS 390 for IBM big machines. Android can be POSIX compliant. All of the FreeBSDs are mostly POSIX compliant. Linux is mostly POSIX compliant. And if you don't have enough POSIX compliance on your Unix operating system, you can always install a toolkit that contains most of the okay, and that would be, for instance, what's the name? BusyBox. So BusyBox is a single executable that can act as BG, break, sh, kill, ls, and many of the Unix executables. Just a single executable. Replaces the basic functions of more than 300 common commands. So these would be built-ins, shell built-ins, plus the shell, plus Unix executables. busybox.net. Okay. The GNU project has written replacements for most of the Unix POSIX command line executables. So there's the BusyBox possibility. FreeBSD has its own FreeBSD base has its own implementation of the Unix POSIX executables. Android has some other ones. Okay. So if you know the POSIX standard command line, you're covered in a ton of operating systems and other environments that are not operating systems, such as Cygwin, Min, GW, etc. Windows subsystem for Linux. Things for DOS. And other operating systems that are not really POSIX compliant, but they can have a compatibility layer with POSIX or with Linux. Okay. What else is there? So we know what are the names of the executables. We know what are the built-ins, the shell built-ins. We know how to determine what's my shell. We go which sh. We go man sh. We go built-in. The most important thing is to know what's the name of your shell, and then you're able to search on the internet and see what are the features of that shell. Okay, there's the things which are written like string, parentheses, then one, then parentheses. These are references to other man pages. So we know there exists a man page which is called built-in. So we go q man built-in. Okay, these are all of the built-ins that are part of the shell minimum UNIX POSIX compatible shell in FreeBSD. Okay, these are other available man pages, so you can go either man csh and parenthesis 1, no, not that, and space 1, no, man 1 chs c shell, like that. So either man and then the section 1 and then the executable csh, or just man csh when there's just one manual for that thing in just one section, then it's going to find that and automatically load it. There's, I don't know, 8 sections and executables are in section 1, in this case in FreeBSD. Okay, so at the end of the man page, you have references to other man pages sometimes. And you can see them with, in the see also chapter, you can go / to search and then write C space also, it will take you here. And then all of the things with parentheses and then one single digit inside of the parentheses, those are manual pages. So you can go man TTI, for instance. And it will look in all sections. It will find just in section 4, so it will load that thing. Okay. We know how to bind together executables using the vertical pipe or greater than. We know how to redirect standard output of files or from one executable to a process to another. And then the only things that remain are the advanced executables that exist in POSIX, which is sh. This is the shell. The shell, you can create a shell script and run that thing. So how do we do that? You need an interactive text editor. Let's go with that. a.sh. So we go shebang. Okay. So this is an example of one of the complex executables that exist in the UNIX standard POSIX command line executables. So this is sh, the shell. The shell can run things either interactively, you write something in the command line and then you press enter. The command line will be executed, maybe a process will be created as child of that shell process. The standard input, standard output, standard error, the 3 standard streams of the child process will be bound to the sh process, and then you will be able to put standard input via command line through sh, and then that thing will be forwarded to the child process. So to write, if you write a key, you press the letter key on your keyboard, that thing will arrive at sh, and sh will send it via standard input to the child process. And the output is the reverse way. Output is generated by the child process, written to, for instance, standard output. Standard output is connected to the parent process, which is sh, and sh will display it via bash, via ssh, via bash, via console, via X. So there's an entire pipeline that sends a key that I press on the keyboard to the correct process, which is in this case the child of the sh process. and that takes the strings that are written to the standard output of that child process of sh and displayed on my screen. So this pipeline can be, I know, 30 processes long sometimes. And each keyboard press traverses that pipe, and each character written to the standard output will travel that huge pipeline back on the reverse order. Okay, so we create a file which is just a plain text file which contains commands. So we can go ls-la/ I put a new line because that's the way I do it, and then I'm inside of an SS, which is the simple editor from FreeBSD base. I don't know how to save, but it has a map on top. So it says to save and exit. What do I do? Escape menu, ASCII code, end of file, top file, command, search, begin, delete, undelete, prev, back, forward. ESC, enter to exit. ESC. Leave the ESC. So I pressed ESC, and now the escape menu has started. And I say A, which means enter, leave editor, A, save changes. So the entire application is called SS, simple editor, and is a TUI application, text user interface application. TUI applications use the entire terminal. So that's why they can display menus, ask for questions, refresh just a single line in the middle of the display. TUI, text user interface. Save changes. I press enter because A is pre-selected. And then a new file was created where inside of my home, I'm the user administrator, my home is /home/administrator. In here I should have a file called a.sh. I can list it with less. Okay, Q to exit less. Or with more, the other paginator, a.sh, Q to exit. I have cat, which is concatenator, which can take a list of files, and it will write all of those in successive order to the standard output, which means to the terminal. Okay, so cat something, then cat the name of a file will list that file. Or I can go, so these are for viewing, and then for editing I have ss a dot. I have auto-completion, I go a dot, and then I press tab, it will auto-complete the rest of the file, and then I press enter. Once I press enter, the shell sh will take the command line and will execute it. So it says ss not found. Not ss, ee. Easy editor. Okay. So I need to exit, so I go esc enter to exit. That's written in the map that's on the top of the page. I go enter to leave editor. And the other editor that everybody is afraid of is VI, not Vim, but VI. The original visual interactive editor from POSIX UNIX. Okay, with many tildes, with modes and stuff like that. So I can't write anything because I'm in the normal mode, which just allows me to go up and down, left and right. If I write A, it will enter append mode. It will not actually write an A. So we go escape, escape. Okay, to exit append mode, back in normal mode, we go W, U, now. We go colon, so escape, escape, then colon to enter the command line which is at the bottom of the screen. So colon for command line. Then I go Q, I would just want to exit, quit. Q is for quit. And then I want to quit now with a bang, the exclamation mark. and I go enter. I go clear. Okay, so now that I have a file, I can execute it with sh, which is the shell. I.tab, and I press enter, and whatever is inside a.sh will be executed. So any of the command lines that I have run in the last hour, which are all available inside of sh, if I go up key on the keyboard, up arrow key, like this, up arrow key, which means back one in command history. Right, all of these I can copy them and paste them inside a.sh. So I can create a perfect command line that does whatever I want. I test it many times interactively inside of sh. You know, mega complex command line like such as this. And when it's done and really good, then I can go back in history with the arrow keys. I can copy it with just select. Let's find the line which does something. Cut a.sh, this thing. I select it, which means not clipboard but primary in X. And now I can edit the command, and then I can go paste. Okay, and I go paste, middle click, enter. So this way I copy the good command lines from sh history, command line history. I place them in a file. I give this file the extension sh, and then in the future, whenever I need these commands in this order, I can execute them all at once by just executing a.sh. Okay, let's save, escape, enter, enter. And now if I go sh, which is the command line interpreter, but we're not going to run it in intermediate. So if you just go sh, it will start the shell, the command line shell in interactive mode. So it will just open a TUI thing where you can write commands and press enter. That's the interactive mode. But you can also go and use it in command line mode. So you go sh and then you give it parameters. One such parameter is the name of the file. Okay. So what this thing did, it ran ls -la, so it listed what / which is the root directory, and then it did cat a.sh, which is this file was listed to the standard output. So these two lines are the result of this line, and these lines are the result of this line. Okay, so shell we can use sh both in interactive mode, we run the command line and press enter, or in batch mode or command line mode where we go sh and we use it as a programming language interpreter, such as we would do with awk or Perl or Python. So we go the name of the interpreter space the name of the file that contains source code in that programming language. And that programming language in this case is sh. Okay. And then if we're too lazy, we don't want to go sh a dot something every time, which is why not, right? Why not just go sh space and the name of the file each time? But if we don't want to do that, then we can turn this file a.sh into an executable. Right now it's just a plain text file. Let's make it executable. So we go Ctrl R to search in the history backwards. We go EE, which is part of a command line. in history it found ee space a.sh, so easy editor space the name of the file to edit. I press enter. It started ee with the parameter a.sh, and now I'm going to turn a.sh not from a plain text file to an executable file of type shell. So we do that with a shebang /bin/sh. So this line is magical. You need to have it. And then I put a new line, and then the old body of the file, which just contains copy-pasted lines, sh valid command lines. So I create a valid command line in sh, I test it, it works okay, then I paste it into this file. At the start of the file I put the shebang, so this hash mark, question mark /bin/sh, and then new line. I save the file, I go exit, leave, save. If I look at the contents of the file, if I view the contents of the file, it looks like this, a.sh. In order to run it, you go, because it's not in the path environment variable, it's add a.sh, so my home is not in path. All of the executables that are not in one of these 5 directories needs to be qualified with the relative path. So we go // which is relative, dot means the current directory, / and then the name of the file. So I go dot, which is the current directory, / and then the name of the file. If you use a relative path like this with slashes in it, it will not search a.sh in all of these 5 directories that are part of the path. We don't want it to search. Maybe there's an a.sh in here. We don't want to risk anything, so that's why we're fully qualifying this sh. I say don't search for a.sh in these 5 files, 5 directories. I know exactly where it is. It's in this directory. So current directory / the name of the file. I go enter, and it says, I see that you want to execute this file. sh has started and says, I see that you want to execute the file as it is, ./a.sh, and says permission denied. What does permission denied? I'm an administrator and I can run things on my home directory, and I can see that I could run those because I went like this and it worked correctly. So why then it doesn't work when I say ./a.sh? Because sh looks at that file and says I should run this thing as an executable, but then this file is not marked as an executable. What's marked as an executable? rwx, right? Remember the name of Rob's channel, so rwx. These are called the mode. Okay, ls tilde, which is where am I? pwd. Okay, I go ls, it will list the current directory. It says there's an a.sh, right? And let's go ls-l for long, and it says that a.sh exists, was created today, 23rd of July, has 30 bytes size. The content of the file has 30 bytes size. The file has this name. The name of the file is not part of the content. The content is just the thing that you see when you go cut. When I go cut sh a.sh, it just shows displays the body. The body has 30 bytes in size, and is this content in there. This. So shebang bin sh, new line, ls, new line cat, new line. That's the entire content of the a.sh file, 30 bytes. Okay. And the file is owned by the user administrator, which is me, and is owned by the user group administrator, which is my own user group. In Unix, or at least in Linux, usually all users are member of a group which has the same name as the user. So if your user is named administrator, then there will be a group which is called administrator, and your user is member of that group administrator. And when you create files, the files by default are owned by you, administrator, and are owned by your group, which is administrator. So this is what it says in here. This is the chmod thing, the chown thing, and this is the chmod thing. So this is a what's that thing? UNIX wiki permissions. Or chmod. So permissions are not complicated things. The complicated things are ACLs. Okay, but are simple things. The simple things are R, which means readable, W, which means writable, X, which means executable, S or T, which means set UID, GID, or sticky. We're not going to abuse these things. So we go RWX. And then there's other possibilities. If it's a directory, it could have D. If it's a char file, dev file, whatever, it can have a C in there. So what we do is we ignore the first character because we can't really change it. In this case, desktop is a directory, so it's shown in the chmod line in the Unix permission as a D. This thing is a file and is shown with a minus on the first position on this column. So D minus D minus D. This is the directory, it shows D. This is the directory, it shows D. These two are files and have a minus. And then there's 9 characters in pairs of 3. So the first 3, RWX, says that the user that created, which is called administrator, can read, write, and execute this directory. Which I don't know what it means. Then the next 3 pair, RWX, means your group. So my group, which is called administrator, can't do anything. Can't read, can't write, can't execute. And then the last 3 characters are for everyone else. So all. So no, everybody else cannot read, cannot write, cannot execute this directory. Back to the a.sh, as the first character has a minus, so it's a file, not a directory. Then the first pair, RWX, it says administrator, my user, can read, can write, but cannot execute this file. That's what SH is complaining about. Says your user, which is administrator, cannot execute, doesn't have the X bit in here for your user in the first pair of 3 for your user for this file a.sh. So it basically looked at a.sh. For my user, it looked at X. Is there an X in there? There's no X. Okay. Am I member of a group? Yes. Of the administrator group? Yes. Does the administrator group have permission to execute? No. Am I member of everybody else? Yes, I'm member of everybody's. All users are members of everybody else. Can everybody else execute? No, because it doesn't have an X in here. Okay. So what it wants me to do is to put an X either here or here or here. So I should make this file executable either for everybody or for my user group, which is called administrator, or for my user, which is called administrator. So let's do it just for user administrator. I go chmod user plus X a.sh. List again. So just for my user, which means just for the first pair, this thing, it put an X, which I said add the execute bit. we put it in here. Okay, so a.sh now is executable by user administrator, not executable by the other user members of the group administrators. There's just one user member of the user group administrator, and not executable by anybody else. There's a special user, the super user root, which can do many things, including taking ownership of this file. Okay, that's the emergency user. We're rarely using that user. Okay, now if I try to run /, so not to search a.sh in path, and then the name of the file, it will gladly execute it. How does it do that? So again, when you write it like this, sh, and press enter, sh takes this entire line and tries to execute it. It sees that you want to run from this directory this file. It looks at this file, has execute bit set in the permissions for my user somehow, either directly through the user or through the user group or through everybody. It's set on just my user. And then it tries to execute it. For that, it reads the file. And on the first position, it sees the shebang. So it knows that it should spawn an sh process, and that sh process should run the rest of the lines. So in the shebang, I could say, don't run it with sh file interpreter, run it with Perl, or run it with PHP, or run it with some other thing, Python, right? Python. So that's what shebangs are for. When the shell the shell interpreter tries to execute the file, it knows what subprocess to spawn with which command line. Okay, so this concludes the complex executable sh, and now we have just 4 more complex executables in the UNIX POSIX standard command lines. There's grep, which we already used. I called it with no command line parameters, so it showed the help automatically. You can learn grep by looking at some examples, and then the big part of really learning grep, aside from the command line parameters, so you can search inside of the contents of a file, you can search inside of the contents of all of the files in this current directory non-recursively or recursively. You can search case sensitive, so that's half of the thing that you need to learn about grep, what are the possible command lines, right? And you can learn, for instance, from the manual. And then the most complicated thing is if the grep supports regular expressions, and it does, then you need to learn the syntax of the regular expression. Regular expression. So learning regular expressions take about an hour, a day to learn. You need to try them one by one and see what they do. So if you search for car, it will find this part of the string. If you search for $10, it will search for the not like that. If you search for something $, it will search for that thing at the end of the line, because $sign identifies the end of the file. or the end of the line. Okay. And so this character matches the start of the file. This matches the end of the file. Any string sequence matches this exact same string sequence, either case sensitive or not, depending if you use the case sensitive parameter to grep or not. And then question mark can match any string. Zero, no, not that. Dollar can dot can match any string. So let's see an example. How do you do? Grep file pattern searcher. So pattern in file. We go grep a and then the name of the file a.sh. So it lists all of the lines inside of that file that have an A on it. So the first line of the shebang doesn't contain an A, then the empty line doesn't contain an A, the two lines contain an A. If I put just a character in here, it will search all of the lines that contain that character and those will be returned to the standard output. If I put more than one character, such as LA, it will search that substring. So LA is a substring in my case. Okay. If I search for the end, it finds all of the lines that have a line ending, and all of them have. If I search for H and end, it will find the two lines with which end with H and then a new line. If I search for slash or for .sh and then $, it will find not .sh and then the end of line, because dot is special. So I need to escape it with backslash. Okay. Not it still found slash. Why did it do that? How do we escape in this grep? I don't know. Okay. So this matches all characters. This matches the characters, one character in this set. So for instance, A, B, C. Right? There's a B in here. There's an A in here. There's an A in here. So this is one character out of this set. Okay. So this is one character out of this entire set. And then there's the negation operator, which says any character that is not in this set will be mashed. For instance, what? I have no X. Okay, then there's the OR operator, there's pairs, which are sub expressions. Then you can have to have these characters, for instance, at least once. I know. Does it expect? Well, I don't know exactly the regular expression syntax for grep. I know the regular expression syntax for other things. Okay, so the first complicated complex executable is sh. The next one is grep. Then there's add. Where are you? ed, the non-interactive editor, this thing. Control C, Control D, I don't know how to exit it. Which ed, I don't know how to use it. if you ever get to a need for such a thing, then you can use your phone to search the internet to see how to use ed, but you're mostly never going to use it. Okay, but then sed, you're going to use sed. So sed is what? A stream editor. So takes the, in my case, takes the input file and replaces it. Replaces the matches that grep would find with something else. So for instance, you want to go sed and what, replace something, 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 and then g. Okay, in a.sh, and to write that thing to the standard input, standard output. And then it says there's two regular expressions in here. Between the first two slashes, there's a regular expression, and then the second one usually is a string, a regular string, not a regular expression. Okay, so let's replace the first regular expression with something that's valid. For instance, sh. So let's replace the string sh everywhere with the string shell with an uppercase S. Okay. So it took the first line. If sh, the regular expression, is not matched, then it writes the thing to standard output. It's not the case because in here there was sh. It matched, and then it replaced the match with the second thing. So the first thing and the second thing. It found the first thing in here, it replaced it with the second thing in here, and then it wrote the entire new line to the standard output. The next line is empty, doesn't match the first thing, no need to replace with the second thing, just write it as is to the standard output. Third line doesn't contain sh, doesn't match, doesn't need to be replaced, just write it as is to standard output. The next one contains a.sh, so it matches sh, which is the first thing. It replaces that thing with the second thing, so it's now cut space a.shell, it writes the new line, and then there's an empty line, doesn't match sh, doesn't need to replace, writes it to standard output. So basically it's exact same identical file as a.sh, but all of the pairs sh, these two, were replaced with uppercase S and then HELL. That's what sed is usually used for. Okay, so we did add, sed, grep, sh. There's just two more remaining. No Perl. Okay, no Perl in the base. So there's only awk. There might be print. Okay, awk. Awk is a command line interpreter for its own programming language. You usually run a command, a source code line of Perl, of awk, like this. So you go awk and then the awk command line, and then you press enter. Okay, let's see an example. Print is the most common one. Print $1 prints the first column, the first record. There's an R that's commonly used, an F sometimes used. This is how a program looks like in awk. Okay, so it's a programming language. In here it takes a text file and outputs nr, which is the row number, not nr. What is that thing? The current count of number of input records read so far. So this is the thing, nr. So this is 0, 1, 2, 3, 4, 5. Okay, that's why it can write here increasing numbers with uppercase N, uppercase R. Okay, and this is the rest of the line. So this is an R and then the rest of the line. This thing. Okay, but then how do we run a awk with awk something over a file? Yes, let's see this. Awk just print an R like this. Okay, so it takes each line inside a.sh, and instead of writing what's on the line, it writes nr, which is the incrementing auto-increment integer. And we can go print $0 and separate it by what? We can use the same print instruction. So print nr and then space and then $0. Okay, that's what awk is used for, is a programming language. The awk executable is the interpreter for that programming language. Either you put the source code of programming language inside of the line, that's after awk space, you put the entire source code line, or you put it into a file and you tell awk to execute that file. Like this, a file with this syntax and structure. Okay. And the very last one, complex POSIX compliant UNIX command line is VI, which is the visual text editor, which I don't know how to use, but still we can VI. Where are you? So VI, how do you survive in VI? You can navigate with your arrow keys. You can exit with escape, W, Q, and the exclamation mark. You can, if it's you somehow managed to edit this thing, like you need to press I to enter input mode. I know, I, delete mode, D mode. I don't know how to do this. Okay, if you managed somehow to edit the buffer, you can write it E, A, L, delete. I don't know how to use it. So I don't know how to edit or change modes, but I know how to write whatever I change. So that's escape, colon, write and Q. So WQ now, bang. Okay, so it wrote to a.sh. And then the most important feature that RWX Rob always talks about is the fact that it can take a line that's inside of the text file, execute it, and replace the occurrence of that line with the standard output of that line, executed using sh. And that's why VI is compatible with the Unix philosophy of doing one thing and doing it correctly, because VI doesn't have any extension methods, anything, doesn't have plugins. The only plugins is the fact that you can write whatever command line you want on a line inside of the text editor, and then replace that text with the standard output of taking that text, executing it with sh, creating a process. The standard output of the testing is taken and replaced in the text editor. Okay, let's see an example of that, and then we'll finish it. V execute current line, replace std out. You can write any content on the current file into the standard input of another program. Okay, let's do that. So we go v, a new file b.sh. We go insert mode, echo 3, new line. Then exit insert mode. Now we're in normal mode, the one with navigation, colon, and then take the text, echo 3, write it to standard input of shell, the shell process. Only the current line, okay. So I need to be on the line. W write to standard input of sh. Okay, so it wrote 3 for a millisecond there. So it wrote 3 on the penultimate line. But we don't want that. We don't want to see the output of the current line. What if the current line in the VI text editor is executed via the shell, and what's the standard output of that thing? We don't want to do that. We want to replace this entire thing, echo 3, with the result. Okay, so for that we go insert mode, and then what's the command line for seeing the date? Okay, date. Insert date. Where are you? Escape, insert date. Okay. Escape, insert, delete. Insert, delete. Okay, doesn't really matter. So we want to execute the current line, and paste yanked line below. What? Well, I don't know the exact incantation, but similar to how can I run this command, which is colon dot write. What was that? The previous thing that I did. Bang sh. Okay, so I know how to get the standard output of the command that's the current line, but now I want to replace the current line with the standard output of the current line, which I don't know how to do. Replace current line with std out sh. Not right, but yeah, so let's see. Okay, so escape, no dot, replace, bang sh. Control C. Escape, R, bang, sh date. -C. Okay. sh -c date. Okay. sh -c date. Well, I give up. I don't know how to do this, but it's an important thing to know when you're in such a limited Unix command line environment. When you only have VI as the interactive text editor, and that thing is really limited because it's not Vim, it's VI, and doesn't have any plugins, doesn't have any Python, Perl or something, a way to enhance its functionality. So there you really need to do things such as write, I know, the name of a file or a directory inside of VI, and then execute that line, get the standard output of ls listing that directory, and then paste that std out in your VI text editor. So that's it. Thank you very much.